Hi everyone, my name is Inaya. My drug is Hytrin, which is the brand name, and the generic name is terazosin hydrochloride. I just want to let you guys know before I got started that I'm going to be doing like all of the pages on this one structure, so I'll be adding them like singularly. Okay, so we're going to start off with a carbon right here. And that carbon is going to have a single bond with a oxygen. That oxygen is going to have a single bond with a carbon, which is going to have a single bond to another carbon, which this is going to have a double bond with a carbon right here. This carbon is going to have a single bond with an oxygen, which is going to have a single bond with a carbon right here. And this oxygen is going to be this carbon is going to be single bonded with a carbon right here. This is going to be double bonded with a carbon. And this carbon is going to be double bonded with the carbon right here. And then these are going to have a single bond between them. This carbon is going to, can you see? Yeah. This carbon is going to be, single bonded with a nitrogen. And this carbon is going to be single bonded with a carbon, which is going to be double bonded with a nitrogen. And then this nitrogen is going to be single bonded with a, carbon. And then there's going to be a double bond between this, and the reason that there's a double bond between the carbon and the nitrogen is because nitrogen is one of the most electronegative elements, and it stabilizes it with the double bond. So from this carbon, we're going to do a single bond with a nitrogen. And then this nitrogen is going to be single bonded with a carbon. This carbon is going to be single bonded with another carbon, which is going to be double bonded with the nitrogen. And then this is going to be single bonded with a carbon. And this nitrogen is going to be single bonded with a carbon. And these are going to have a single bond between them. And then this nitrogen is going to be single bonded with a carbon, which is going to be double bonded with an oxygen. And this is going to be single bonded with a carbon right here. And this is going to be double bonded with an oxygen, which is going to be single bonded with a carbon, which is going to be single bonded with another carbon. And then this carbon is going to be single bonded with a carbon right here, and then these two are going to be singular bonded. And this carbon right here is going to be single bonded with a nitrogen, and then there's going to be two hydrogens that are singular bonded from that. Now I'm going to be adding the hydrogens and lone pairs. So there's going to be a lone pair right over here. Two lone pairs. We're going to have a lone pair with this nitrogen to stabilize them, of course. And then lone pair, lone pair, lone pair. And we're going to have two lone pairs right here. We're going to have two lone pairs right here. And then we're going to be adding the hydrogens. So it's going to be single bonded hydrogen right here. Another one. Another one. And then from this carbon, we're going to have 1, 2, and 3. And then from this carbon, we're also going to have 1. And then we have 2 right there. And then we're gonna have 2 with this carbon. We're gonna have 1 with this carbon. And then we're gonna have 2 and 2. And from this carbon, we're gonna also have 2. And that's that. Now I'm gonna move on to the molecular geometry. Yeah. Okay, so for trigonal planar, I'm gonna be highlighting them in yellow. So we can go ahead and do that first. Those are gonna be all of my, well, not all, but a lot of my carbon bonds. And the reason that they're trigonal planar is because they're gonna be 3 elements that are bonded to a central atom. So this one, this one, this one, this one. We have this one, this one, this one, this one, this one. I also have all of these. And yeah. Oh, and this one, which I also just see, I did not include a hydrogen bond right there. Okay, so that's that. And the next I think we're gonna do is bent 120, which I will be doing in blue. And the bent 120 is with 1 lone pair with 2 elements attached. Okay, so there's only 1, which is gonna be this oxygen right here. And then we're gonna do tetrahedral, which is gonna be in orange. Tetrahedral is 4 bonds to 1 central atom. So there's only 3, which is gonna be this carbon, and this carbon. Next up, trigonal pyramidal. Which is gonna be in green. Which is 3 elements attached to central atom. I just put that down. So it's gonna be this nitrogen right here, this nitrogen right here, this nitrogen, we're gonna have this nitrogen, oops, and this nitrogen. Wait a second. Yeah, sorry. Okay, and that's gonna be that. And then lastly, we have bent 109, which I'm gonna be doing in purple. Okay, so bent 109 is 2 lone pairs with 2 elements attached, and we only have 2, which is this oxygen and move it this way. Oops. Okay, that oxygen. Next up, I'm gonna be doing polar bonds. So we have, and then after I will be highlighting them in pink. And then I can put polar bonds. Okay, so we have one polar bond right here. Another one. And then we have one right here. Another one. And then we have one right here. And then we have one right here. I'm gonna highlight those real quick. And then we also have one between this and then we have one going here. And then we have our last one, oops, which is right here. And then I'll highlight those. Okay. And with that being said, this hydrogen/terazosin is water soluble because of the polarity and the H bonds. Next up, we are going to move to my structure having like water bonds. Sorry, I don't know how to say it. Okay. So from this hydrogen, it's going to be an acceptor. And then from this one also. Acceptor. And then we're gonna have this nitrogen be a donor. So we can do and then this one also. Donor. And then we have this nitrogen right here being a donor. We're gonna have this oxygen being a donor. Move this down. And then we have this oxygen being a donor. And then we're going to have this oxygen being a donor. And then we have this nitrogen being a donor. And that is it for that. And then we have the hydrogen bonding with water. This one I had to do on a separate page. Okay. So first I have, First we have this hydrogen, which is going to be an acceptor. We have this nitrogen, which is going to be a donor. I should have been doing this in red. Which one of these are red? We can do this. Donor. We have this oxygen being a donor. And we have this hydrogen being an acceptor. We have this oxygen being a donor. Okay, we have this fluorine being a donor. We have this hydrogen being an acceptor. We have this oxygen this oxygen being a donor. This oxygen being a donor. And yes, that is my page 7, hydrogen bonding with water. And next up I have is calculating the molecular formula and molar mass of my drug, Hydrin. So, the molecular formula is carbon, 19 of them, hydrogen, 25 of them, nitrogen, which is 5 of them, and 4 oxygens. Okay, so first we have carbon, which has a molar mass of 12.011. Then we have hydrogen, which has 1.008 molar mass. Nitrogen has 14.01. molar mass, and oxygen, which has 16. Okay, so then we're gonna multiply by 19 to get 228.209. We're gonna multiply this by 25 to get 25.2. We're gonna multiply this by 5 to get 70.05. And we're gonna multiply this by 4 to get 64. And then when you add these up, you get 387.5 grams per mole of hydrogen. So yeah, that's the molar mass of hydrogen. And I think that completes my structure. So thank you.